Here we go, let's sketch. Exercise 14J, question 1B. Let's do this. X is an element, 0 to 2 pi. Alright, first things first, what are we going to do? What did I do in the last session? How to sketch, to start sketching, the first thing I look for. What do we look for? You want to find your periods and your quarter cycles is your first part, but just to start off with, you also need something else. I always do something before I find the quarter cycles and period. Amplitude. You want to find how far it goes up and how far it comes down. Okay, so what's the maximum minimum? That's what you want to work with. Then you work out your horizontal phase. Yeah? So, just quickly, I'm just going to make sure I get all the rolls right. P. Alright, cool. Now, first things first is your amplitude. You want to know what your maximum and minimum values are. So, if we look at our amplitude, what is my current amplitude? Can I please have Jamal, who just came? What's my amplitude? 2. Fantastic. So we know amplitude is 2. So in your mind right now is this graph should have a maximum value of 2 and a minimum value of -2. But what else do you have to watch out for? So you got a maximum, minimum, or something else, something that changes this. The square root 3. Okay, this tells me the transformation. This is what I'm trying to teach you to read. This tells me stretching. This tells me also horizontal stretching. But this one tells me translation. So it's up and down. So if you move it up and down, obviously you affect your maximum, minimum values. So now my maximum, because it's now going down negative root 3, it is instead of having, whoa, what happened there? Instead of having 2 and -2, I now know I'm shifting that maximum minimum down by root 3. So I know, this is all I would do. I just put in those values and I say it's 2 minus root 3 and -2 minus root 3. That's all you need to understand. Okay, so when I sketch it, the first thing I do is I do this. I do an axis. Actually, technically, you know, it's only 0 to 2 pi, so I'm going to start there. And I say, I just do a top and a bottom, and I say this is 2 minus root 3, and this is -2 root 3. Okay, but because I know it's shifted down a bit, I might just make this look a bit uneven, so it makes a bit more sense. 2 minus root 3, 2 minus root 3. Okay? So now I've got my top and bottom. Remember, you don't have to do the dots. I did the dots last time for you guys to see how I'm sort of solving it. You don't need to do that because then you've got a lot to rub off. Okay, unless you do it in Greyload first and then you do it over in pen, then it works fine. It'll look nice. I normally just keep that top and bottom and I just find the middle. Now, where would my middle be then? So you've got your maximum, you've got your minimum. Where would the middle be? Negative root 3. How do you know? Because initially it was negative 1 to 1 and the middle was 0. So from 0 you went down by root 3, so naturally the center line, middle line has to be negative root 3. That makes sense, right? So I now know the middle is negative root 3. So if this helps you, I'll just draw the dots so it helps you again, and then eventually you don't have to do this. Okay, so we know this is the top, this is the bottom, this is the middle. Now all we need to find, so once we know the top, middle, bottom, you just got your period. Once you know your period and you know your quarter cycles, you're done. You see, it's just the intersections, and you can find all the way to the end points, and then you put them all together, right? So, here we go. Our next step is to find our period. What is my period equal to? Can I please have Bruce? What's my period equal to? Fantastic. 2 pi over 2. This is responsible for your horizontal dilation, and because you're shrinking it by a factor 2, you're going to divide your domain or your period by 2. So therefore, 2 pi on 2 gives you a period of pi. So you now know one cycle takes pi units, but we want to find quarter cycles. So quarter period cycles. So we're going to find quarter period cycles by dividing it by 4. So quarter means divide by 4 or quarter. Quarter cycles will now equal to pi divide 4. So I know quarter cycles pi and 4. Your first step is to find your first coordinate. And you know to move to the next quarter cycle, it is every quarter. Now it's nice when you read the transformations. This is a sine graph. It's a positive sine graph. The positive sine graphs normally look like this. Like that. That's your positive sign graph, where you got these main points here. That's your positive sign graph, and it doesn't move left or right. See, if you let 2x equal to 0 and you solve for x, it's still equal to 0, so it doesn't move left or right. So the center point still starts. Yeah, the only thing that changed was it went down by root 3. So that's my first point. That's where I know my first coordinate is. That's right there, my first coordinate. So that's my first one. I'm going to use that to find my next quarter cycle. So I'm going to start here. I'm going to use a green dot so we can work with this. So here we go, green dot. I've got my first point. To get to the next point, I need the next quarter cycles. You see, I'm just going to draw my quarter cycles right now. I want to know what my quarter cycles are. Okay? Find your quarter cycles to go from here to the maximum, because that's what my sign graph looks like. That's positive sign. All the way up to the top. Then middle, bottom, middle again. So to get to the next quarter cycle, I know I need to move pi 4. So I started at 0. This is where x equals 0. To move to the next quarter cycle, it obviously has to be pi 4. Okay, so we now know, all right, this is pi 4. Now, even though you know it's pi 4, this is not what you want yet. You see, you want to know the distance. You want to write, especially when you move left and right, it changes that. In our case, it's pretty easy because we're not moving left and right. It's actually easier to sketch. You know, it's from pi 4 to the next one, you still add pi 4. And conveniently, you didn't have to change anything. It's just an extra 1. Every time it's just going to the next one, you're adding an extra 1. So if this is 1, the next one's 2. The next one's 3. The next one's 4. The next one's 5. Unlike the one we did previously in the last lesson, we may have to find this same denominator, and that was a bit trickier. Yeah, that's only because you're moving left and right. If you're not moving left and right, this is really easy. So now you've got all your quarter cycles, you know, oh, well, that's 2 pi 4. This is 3 pi 4. This is 4 pi 4. And that makes 1 pi. But remember, my domain was going from 0 to 2 pi, so I just need to do another one of these cycles. And that's easy. You can just follow on. So if I just rub all this off and make space for it, we can now sketch it. We can say, all right, it's every pi 4, and I'm going to use blue to carry this on, and I'm going to use green again. So here we go, pi 4. This is 5 pi 4. This is 6 pi 4. 7 pi 4, and finally 8 pi 4, which makes 2 pi. So I finished my domain, and that's what I'm saying. Over time, you don't have to do those dots that I'm doing for you right now. I'm just doing it so you can see. So I've got my first dot, maximum, middle, bottom, middle, top, middle, bottom, top. And then you can sketch. So you just put it all together. I just missed it. Oh well, whatever. Okay? And that's a much easier way to sketch, but minus all those dotted lines that I'm doing. So if you don't mind, if you feel that that helps you to have that sort of group going, do it in Greyland, go over the graph with your pen, and then rub off the Greyland. That's perfectly fine. So remember, the only thing that examiners normally look for if you're sketching circular functions is you don't need to label the turning points. There are too many of them. Okay, you don't need to label the turning points, but you do need to label endpoints. So endpoints, x-axis intercepts, which now you all know how to do. We spent 3 sessions on solving it, and most of you were doing it really well. You now can label the x-axis intercepts and any y-axis intercepts. So get endpoints, shape, axis intercepts. That's all you need. Okay, those are your 3 marks for your graph. Any questions? No? Shape, axis intercept, endpoints. That's what I want you to do. So the ones without any left and rights are the easiest ones to do. So you can see all these graphs here, it's only when you have left and right, left and right, left and right, left and right. These are the ones that are trickier to do. The rest are easy. Yes, Jamal? So you don't get marked. Don't get marked? No. The quarter cycle is just the way for you to sketch, but you don't get marks on the quarter cycle. Yeah. All right, so that's what I want you to do this session. I want you to practice sketching the graphs. If you're still struggling with solving, I want that down first, because that's the hardest algebra technique. Now it's just graphing. And you see graphing has less algebra. It's more about sort of reading the graph and sketching it. But the algebra comes from everything we did before. Exact values, symmetry properties, all that is what I was spending time to make sure you have. Okay, that's why we skipped A, B, C, D, and we jumped right to E and F. Yeah? Because I'm trying to give you this overall picture on how to sketch a circular function. Cool? Alright, we'll leave it at that, and next session I'll teach you how to use a CAS along with a tan, how to sketch tan graphs. Tan graphs is so much easier than sine and cosine, so you can do that real easy. Yep. No, I didn't have that. I just normally pick as we go. Did you want to go ahead? Is that why?
No, just to go fast.
Righties. Because I kind of jumped back and forth just to make sure that you had the skills.
No rush. Just maybe by the weekend.
Yeah, I can easily do that by tomorrow. I'll easily do that.
Wow. You got homework with the tram, sorry.
Please. It's all here. I'll just write it here right now. Students related. 6.
I'll give you by the weekend, but after that.
Question. Say questions. Alright. Easy.